Some places around the world are more prone to severe weather events than others, but everyone has likely experienced a power outage at some point. The question is, with 21st century technology, why are powerful storms still able to turn the lights out? To begin with, power is produced in generating stations, which use wind, coal, water, and natural gas to create the electricity. That electric current is pushed into a transformer, which increases its voltage to travel long distances through transmission lines that crisscross the country. After the electric current completes this journey, it passes through a substation, where the voltage lowers. It can then be distributed onto the smaller, local power lines. It moves through these distribution lines into transformers, which further drop the voltage so it can enter your home. This is a classic example of an above-ground power line system. But there is also an underground option. It moves electric current in much the same way, but some of the journey happens in wires buried underground, rather than hanging from poles. Considering the enormous task of moving electric current hundreds or thousands of miles to power millions of homes, it seems strange that something as simple as a rainstorm could cause the system to break down. However, power lines are also designed to protect the power grid and the surrounding area. For example, most storms bring strong winds along with them, which causes trees to sway and branches to snap. When a tree branch comes in contact with a high-voltage power line, the power is automatically cut, and then restarted when the contact ends. This prevents the electric current from being discharged and wasted. If a branch snaps and falls onto a power line, the power will remain off until the problem can be resolved. In some cases, severe wind will blow power lines down, or an entire tree will fall across the lines, pulling them down. Heavy and continuous rain can also damage insulation elements and cause blown fuses and power loss. Physical damage from branches and hail, or gradual wear over time, can cause cracks that let water seep in and do damage. Snow and ice storms are even more hazardous, as they can stick to and weigh down power lines, sometimes snapping the cables entirely. Power lines are also frequently struck by lightning, which can overload local transformers and cause major power issues. Trees struck by lightning often collapse onto nearby power lines, causing power outages, even if the trees have been adequately cut back. This all may make it seem like an underground transmission option is far safer and more effective, but flooding and heavy rain can cause problems in underground power lines too. Additionally, with above-ground wires, the problem area is easy to identify and access. If your power grid is underground, it's more difficult and disruptive to find and fix the problem. It is far more expensive to install, access, and repair underground power lines than it is to erect traditional electric poles. Although there are some advantages, the billions of dollars it would cost to implement make it less popular than you might expect. While these systems are constantly being improved upon, power outages will probably always be a part of life, and the lifeblood of the candle industry.